Uh, Very good morning to all my fifth semester students who have opted for this elective, that is the Internet of Things, or you can also call it as the fundamentals of Internet of Things. I hope all of you are safe and sound. So because of this unavoidable circumstance, uh, we are not able to meet each other since March this year. Anyway, uh, the different arrangements have been done to see to it that your learning is continuous, and I hope you have already got your fourth semester results also. I'm very sure that you all must have come with flying colors. Anyway, this process has to go. We cannot stop for a long time. So enough is enough. We have already stopped for 2-3 months now, except your examinations and online class period, right? Um, so from as you have already got the notice from the 1st of September, your all online classes will begin, and accordingly they have already begun probably yesterday only. So now according to the notice that we have received this particular month, that is the September, you will be mostly going with online classes only. Later, depending upon the situation and the revised directions from government or university, so we will definitely think of meeting physically so that you can carry out your laboratory experiments and the conventional learning teaching methods, other things. So to start with the things, first let me give a very brief introduction about this particular elective. I have already told you, some of you had raised queries about what exactly is the content of this subject, or where exactly it fits in. What about the other subject and all? I have very categorically told the data structures and algorithm that will really help you if at all you want to, improvise or enhance your programming skills, which will be really helpful for you to, go with the group discussions or interviews, particularly with the software or IT related companies. So if at all you want to do something in the hardware along with the backup or background of the software, probably this is one subject, because this is concerned with the internet, and this is also concerned with the things. So definitely in the later stage I will tell you what exactly is the preamble for this, and what exactly you are going to learn here, right? In what way this particular course is going to benefit you later in your career and all. But please make sure that you make a clear mind whether to go with this elective or the other one. Let there not be any confusion once you decide the elective. That is one thing. Now if you look at the course content, right? As you can see here, right, it is 18 EEE 514 the subject code. Then accordingly it is a 3 credit course. You can see right in front of my screen, it is a 3 credit excuse me, it's a 3 credit course, as you can see. Okay, and the total contact are 39, right? It's a 39 hours course. And as you can see here, let me very briefly explain the course learning objectives and all. The students are expected to learn the basic concept of Internet of Things, its general architecture, then technology and design principles behind it. The students are required to get the exposure to handling the you know data and understand the concept of cloud paradigm being used in IoT environment. Students are also required to understand the role of sensors in IoT and the basics of embedded computing, besides understanding certain case studies on the specific applications. So this will give you an idea about what exactly we are going to have in this particular course, right? Now, understanding the course outcome, as I have been always telling to you, is also very, very important for you, because since we are under the OBE, the outcome based education, right? So, understanding what exactly the course outcomes are and how they are related to the program outcome, and how you are going to get some kind of attainment as long as your learning is concerned, right? How do you measure them? In what way that will help us in achieving the objectives of the outcome based education? This is also very important. So whenever some committee comes, or whenever some evaluators come here, they may ask you all these things, and you should have an elementary idea about what this course outcomes and how they are mapped to the different program outcomes and all. So now, in this particular course, as you can see here, there are totally five course outcomes, and each course outcome is pertaining to a particular unit. There are 5 units which you will see subsequently, right? So the first course outcome, as you can see, understand the fundamental concepts of IoT, design principles, and different communication technologies used in the IoT paradigm. So now this is basically to understand what exactly is IoT. I will anyway explain these things in detail when I come to the actual course contents, right? And this particular course outcome is mapped to program outcome 1 at a moderate level. I will tell you what exactly is the meaning of moderate level, substantial level, and slight level. Generally, it is all decided by how many numbers of hours are dedicated to a particular CO. That will decide whether it is mapped to that particular PO at a substantial level, moderate level, or slight level. So your program outcome 1, PO1, is basically the knowledge, right? So the knowledge that you are supposed to gain. There are totally 12 program outcomes, which are also referred to as the graduate attributes, right? Synonymously, though they are not directly the graduate attributes. There are 12 program outcomes as defined by our statutory body, AICTE or UGC, whatever it is. So those 12 program outcomes are fixed for all the engineering graduates, irrespective of their discipline. So therefore, the first one is understanding the things. So therefore, this course outcome CO1 is linked to the PO1 at a moderate level. Then if you go to the second course outcome, understand different data handling protocols, aspects of cloud computing. Nowadays, a lot of things are being spoken about the cloud computing, machine learning, artificial intelligence, virtual reality, and all. So, of course, these all paradigms or the technologies are definitely going to rule the world in the coming decade. So, therefore, a little idea or a brief introduction about all these things, how the things are perceived or viewed from the point of view of all these things. If you have some idea, probably in the later part of your career, you will be definitely benefited. So that is the reason why this particular subject is incorporated first time in our electrical and electronics engineering curriculum. Okay, so now this CO2 is linked with the program outcome 1 at a moderate level, and the program outcome 3, maybe I think it is the design, I don't properly remember, with a slight level. There may be certain small design aspects also involved in this. Okay. Then if you look at the next CO, right? If you look at the next CO, that is the CO3 here, you can see here CO3, understand the different types of sensors and the data communication protocols for these sensors as applicable to IoT. You know, the sensors nowadays are playing a very, very important role, right? So they basically uh, play the role of the fundamental, fetching of the information, right? I will come to these things later in a detailed manner. Understand different types of sensors, what these sensors are, and the data communication protocols for the sensors as applicable to IoT. So this is also mapped to the same POs in the similar manner as that was uh, done for the CO2. Then the fourth, uh, course outcome, study and select a suitable embedded platform for IoT applications. There are so many embedded platforms. I will come back to those things. So when you study different things, so finally you should be able to, or you should be in a position to identify or select, okay, this particular platform is better or suitable for a particular IoT application. So that also requires some knowledge, and some design aspects are also involved in it. So these are the POs, right, which are linked to this CO4. Then finally the last, the CO course outcome, analyze the smart grid technology and different other case studies based on IoT applications. So now here it is basically to study some applications which make use of the concepts of Internet of Things, right? So now in this case you have the fourth program outcome, and we have a specific program specific outcome with respect to our department or pertaining to our department. So this is how the different COs are linked or mapped to different program outcomes. COs are basically the course outcomes, what the student is supposed to learn, or what the student is about to gain at the end of the course. The student will be able to, what he will or she will be able to do, that is described by the course outcome. And since these all course outcomes are linked with the program outcomes, you will be able to contribute from your learning of each course into your program outcome. Once the program outcome is linked to different courses, what happens is the overall attainment, right, after a particular student is graduated, right? So once the program is over, program means electrical electronics or computer science or electronics, something like that. So all these things will add on to your program outcome, and finally you will get a certain attainment. So that attainment tells you, apart from your academic performance, 8.5 CGPA, 9 CGPA or 9 point CGPA, whatever the academic performance you are having, apart from that, there is another way of measuring your learning, or there is another yardstick, what we can call, to measure your learning, that is called the outcome based education. This is one of the important components of the outcome based education. So that is again linked to your program outcome, and afterwards again there are so many other things like program educational objectives. After you graduate, after 3 to 4 years or 4 to 5 years of your graduation, where exactly you stand, whether you have become a software engineer, whether you have become an entrepreneur, whether you have become a government engineer or something like that, right? So that is a program educational objective. So now these are the 5 course outcomes, and how they are linked to or how they are mapped to your program outcomes I have demonstrated here. Okay, so now let us go to the next thing here. I will to the next slide now. Okay, yeah. So when I come here, you can see here uh, the table which is right in front of you. For the time being, you need not worry about that. That is for our internal calculation. Now, coming to the subject, right, in the IoT or the Internet of Things, what exactly you need to know before you start studying the Internet of Things. And very fortunately, all these things which have been marked here, right, you are very well aware, right? So the first one is any one basic programming language. C you have already studied in your first or second semester. Digital electronics in detail you have studied in your third semester, and microcontrollers in detail you have studied in your fourth semester. So these are the three prerequisites for you to study the Internet of Things. And of course, it is not limited to that. There may be some other informations required, which I assume that you have not studied some of the network related concepts. Anyway, we will take those things up here. Okay. So now let us slowly go into the course content, right? What exactly you have in this particular course. One second. Okay, what exactly we have in this particular course, that we will look now. um, Now if you look at the first one, okay, I will just reduce its size, okay, so that uh, it is very clearly seen from your side. All these small, you know, technical glitches are very common, right? You should uh, be familiar with these things now. Okay, let me start with this module 1. Okay, so now in this module 1, what you can see right in front of your screen is overview of IoT. What exactly is IoT, right? So now before that, let me give you a very brief introduction about what IoT is, Internet of Things. And probably if I give you one example, so you should be in a position to understand it in a better way. Okay, so now let me say that I have got you know, a big room where there are say 100 fans. Okay, fans. It may be you know, community hall, or it may be whatever it is, right? A big hall, something like that. There are 100 fans. So now I want to know how much total power all this cluster of fan consumes, or how much temperature rise is observed whenever the fan is rotating for maybe a couple of hours or 3 hours or 4 hours or something like that, right? I want to know. Why I want to know is I want to have some alternative if at all my consumption is going above my requirement, or if at all the temperature rise is going beyond the prescribed limit. Okay, so what I will do, the general thing is that you take you know, a temperature measuring instrument. Okay, you go to all the fans, see, wait there, check whether the temperature is within the permissible limit or not. Okay, if it is not, you just report. Otherwise, the total power consumed, you have got a very simple method, right? So you know how the once the power is measured, you can have all those things as your database. But if you want to remotely monitor all those things, you have got some that room where these fans are located somewhere away from you, right? You want to remotely or distantly manage all these things, then what would you do? So you install the sensors there in the fans. Okay, you install the sensors. So these sensors should be capable of measuring the power that the fans consume, and also these sensors may not be the same sensor, some different sensors which are deployed there. They should be in a position to note the temperature rise or observe or the record the temperature rise. So once these things are done, what will happen is all these informations from the sensors will go to a local computer. It will go to a local computer with whatever the methods that you have used there. So from this local computer, using the internet, okay, there may be so many data here. Each fan at 10 o'clock, how much temperature rise has taken place. At 12 o'clock, how much temperature rise has taken place. In the evening, how much temperature rise has taken place. These are all cluster of data, right? How much power is consumed at what time. You will have all the information, right, which is as measured by the sensor, as recorded by your local computer. Then all this data, right, it should be remotely monitored and it should be assessed, right? Once it is assessed, if you want to take it to a remote place, then you must make use of the internet. If you want to store all this data, you cannot always have a pen drive or other mechanisms of storage, right? So they must be stored in what we call nowadays in a general sense as the cloud, right? So it is a basically memory which is a virtual memory as long as the user is concerned. It will be located somewhere, right? You must be knowing your Google Drive and all, right? So in the Google Drive, they give you a 15 GB data, right? But where it is, whether they provide you a pen drive, no, they don't provide, right? So it will be somewhere else. It is in their cloud. It is called as the cloud. So all those data will be put in the dedicated cloud. There the analysis and other things will be done. Okay, the analysis is done. After the analysis is made, the observations are recorded. Okay, so this particular fan, if there are 100 fans, the fourth fan, eighth fan, 50th fan, 74th fan, if they are old fans, they normally, go with higher temperature, right? They come across higher temperature rise than what is required. They consume unnecessarily additional power. So all these informations must be made known to the concerned person. Then finally, the decision is for that person to whether to remove those fans, replace them by a better fan or better fans, right? That is the decision to be taken by the person. So now this particular information should be provided to the person. So now you can understand how the entire situation is conceptualized. You have something somewhere, you have to measure some things there, right? You have deployed some sensors. These sensors measure, but the use of sensors is limited only to measurement. They cannot do anything else there, right? So afterwards, again, there is a limitation or exception. There will be some smart sensors. I will tell you about that, what exactly the smart sensors do, right? So once the sensors measure these things, it goes to a local computer, then it will go to some cloud where all the analysis and other things will be done, which is at a distantly located place. After all analysis is done, the report will come back again to this person. See, these things are found to be little odd here. Either you will have to replace or you will have to manage with whatever you have depending upon your requirement. This is one particular example. Okay, now you have got an umbrella, for example. Okay, so your umbrella, why you take the umbrella? Generally to protect yourself from the rain or very extreme sunshine. Suppose if your umbrella is equipped with something, right? Some smart things, right? Like some sensors which is connected to the weather data. Okay, so if your weather data is very precise, so today 4 o'clock it is going to rain here at Dharwad. If that kind of information is able to get, your sensor should be able to read that, or your mechanism which you have deployed, the smart devices which you have deployed in your umbrella should be able to read that, and accordingly it should give you a warning. Carry my umbrella, okay, carry me. That umbrella itself is giving you a warning. So today it is going to rain at 4 o'clock, please carry me. Or today it is going to be extremely hot at 2 o'clock or 3 o'clock, please carry me, otherwise don't carry me. So this is one kind of thing. Like that, with these two examples, so probably you should be able to understand what I try to convey, right? So the same information can also be seen from the different point of view, and as and when we study this particular subject, we will come to know what exactly we are going to do that. Okay, so now I have only told you how these things happen, okay, but who does it, how it can be done, what is our role as engineers here, all those things you should be able to realize. That you will be able to realize only when you go through the fundamental things, how these things happen, how these things are materialized. That is the work of the engineer, right? So you have got a smartphone with you, right? So many sensors are there, you know what smartphone does. But being an engineer, you should be able to understand how it is done, right? How the things are materialized in the smartphone. Smartphone is a fantastic example of your IoT, right? Probably you should be able to correlate what your smartphone does and what I have told so far. Okay, so with this brief introduction about IoT, let me go with these things now. Um, you can see here IoT definitions overview, IoT definitions, vision, smart and hyper connected devices. I will tell you what exactly is meant by smart and hyper connected device. IoT conceptual framework, architecture, technologies behind IoT, major components of IoT, sources of IoT, and machine-to-machine communication. So this is the first topic that you are going to study here. Uh, the first part of the first topic. Later, you will be studying about the other aspects like what you can see here, the design principles of the connected devices. What do you mean by system? What are layers? What are design? What do you mean by OSI model, open system interconnection model? How your conventional OSI model is and how it is modified for IoT. Then ITU, International Telecommunication Unit or Union reference. What exactly is the meaning of ITUT reference model? Okay, so this is the second part of the module 1 which you are going to study. Then you have the different communication technologies. So probably when you look here, probably some of you may be in a position to understand what exactly I try to tell here. Wireless communication technology, okay, then RFID, right? Radio frequency identification devices. Zigbee, some of you are maybe familiar with this, right? Internet protocol, Wi-Fi, wired communication technology, and the different, comparison of the communication technologies. Bluetooth and other things also you have here. Okay, so that is going to be your first unit where you will have all the general discussions. Then you have the second module where you have the data handling and cloud computing paradigm. Then you have got in this how exactly the data handling is done, right? After, see, the whole thing goes like this. You sense something, okay, then you measure something, then handle that data, right? So then you make the analysis, then you take some decision, right? So sequentially here also we will proceed, right? So in this case you have introduction to internet based communication protocol, then version 4 and 6, TCP IP suite, right? Transmission control protocol, internet protocol, then IP addressing in IoT, how exactly the internet protocol addressing is done in the IoT. Then the data handling, right? Data acquiring and storage, organization of the data, how the data is analyzed, that is also you are going to have, right? Then the next thing is the cloud computing, right? I will now continue with this smaller frame. I'm not going to continue for a longer time now, right? So cloud computing, this is very, very interesting thing, right? What exactly is the cloud computing? What are the different methods? What are the deployment methods, right? Everything as a server, right? The server service modules, service using Nimbits, right? Public platforms, all these things you will be studying in this cloud computing. In the third module, right? In the third module, you will be studying about the sensors and network. What are the different sensor technologies that we are using, right? The different types of sensors. You have the analog sensors, digital sensors, examples, right? Sensing the things, barcodes. This is very much, related to our day-to-day life nowadays, right? Barcodes, QR codes, right? Then motion sensors, pressure sensors, environmental monitoring sensors, right? Party sensing, industrial IoT, actuators. All these things you will be studying in your first part of the third module. Then radio frequency identification devices, technology, principle, design challenges, wireless sensor network technology. So this also comes as the second part of your third unit. Okay. Later you have the fourth unit, which is very much interesting again, embedded computing basics. So in the embedded computing basics, you have the embedded software and hardware units, embedded platforms for prototyping, Arduino. Okay, some of you may be very familiar with Arduino, Intel Galileo, similar to Arduino, Intel Edison, Raspberry Pi, one of the most popular type of the platform nowadays, right? BeagleBone, then things always connected to cloud, prototyping, embedded devices, software devices, gateways, internet and web cloud service. So this is what you are going to study in your module 4. Finally, after seeing all these things, let us look into some of the application of this Internet of Things, right? Wherein you have the introduction to smart grid. So right now you don't know what is a grid. Let me tell you that also. So let us look into what a smart grid is. Then a possible IoT based smart grid, smart home, smart cities, street ride controlling and monitoring. And maybe if you are really interested, for some of you, doing the projects on these things in your higher semester, right? Because once you come to fifth semester, you probably have to have all the fifth, sixth, seventh, and eighth semester one project component with you. This is going to really help you in doing or in executing some of the projects. Okay. So as we have already been instructed, the class in a single stretch should not exceed half an hour. The remaining half an hour is generally dedicated for the discussion with each other. That means you and me. So with this, I will stop the contents which I am going to share you right now. Later, the remaining part of it I will take in my next class. So if you have any doubt or any query, I will come back to you right now, right? You please get your doubts and queries with you. I will come back to you very shortly. Thank you.